Section 6.6 is function operations. I can add, subtract, multiply, and divide functions. Big ideas here. Functions can be added, subtracted, multiplied, and divided based on how these operations are performed for real numbers. One difference, however, is that the domain of each function must be considered. Take note, on page 398 talks about function operations. So here, if I have f plus g of x, I'm going to take f of x plus g of x. Same thing, f minus g of x, f of x minus g of x. I take my entire functions and perform the operation. Here, I multiply them. Here, I divide them. One thing to consider though, our domain here excludes anything that has g of x be 0 because we cannot divide by 0. So we have to be careful there. The domains of the sum, difference, products, and quotient functions consist of the x values that are in the domains of both f and g. The domain of the quotient function does not contain any x values for which g of x equals 0. So our sum, difference, and product are all going to have the same domains, and our quotient is just going to not have division by 0. So the same thing as our sum, difference, product, except it excludes anything where g of x is 0. In example 1 here, we're adding and subtracting functions. F of x is 4x plus 7, and g of x is the square root of x plus x. What are f plus g and f minus g? And then what are their domains? So first of all, for f plus g, I'm going to take f of x plus g of x. And we can put these in parentheses if we want to here. But since all we're doing is adding, we don't need them. I'm going to take and combine my like terms. So f plus g, which sometimes can be written like this, of x, is going to be 5x plus the square root of x plus 7. Now, as far as my domain goes, our domain is always going to start with all real numbers. And then we just exclude anything we can't have. We look for square roots of negative numbers. We look for division of by 0. We look for absolute values that equal negative numbers. Those are the type of things that give us exclusions to our domain. Otherwise, it's all real numbers. So if we look at f of x, 4x plus 7, are there any numbers we can't plug in there? No, we can plug in anything we want to. We can plug in negative numbers, we can plug in positive numbers, we can plug in 0, we can plug in fractions, decimals, irrational numbers, we can plug in anything we want to there. In g of x, is there anything we can't plug in? Yeah, we need our square root of x has to be greater than or equal to 0. Okay? We can't have square roots of negative numbers. So whatever's inside my radicand has to be greater than or equal to 0. So we can either write our domains with x values or with all real numbers greater than or equal to 0. Now, when we're comparing these, we need our domain to work for both. So here, if I can only have greater than or equal to 0, and here I can have everything, the only ones that are going to work for both are the most restrictive, greater than or equal to 0. And this is our domain. If we look at our function that we created when we combine them, it's the same thing here because we have that square root. Same idea for f minus g. I'm going to take f of x minus g of x. And here I am going to put those in parentheses just so that I remember that I have to subtract this entire function. So the 4x plus 7, okay, it's like there's a 1 in front that we distribute, nothing there. With the subtraction though, it's like we distribute a negative 1 we have to subtract the entire thing. There are going to be people who forget to change that sign. Don't let it be you. Okay? Make sure that we change that sign. Once we get to there, it's the same steps as in the adding. We just combine our like terms. So 4x minus x is 3x minus square root of x plus 7. And again, my domain is all real numbers greater than or equal to 0. Same domains here, nothing changed. Feel free to pause here and give this a try if you'd like. We have f of x and g of x. What are f plus g? And f minus g. And then what are their domains? So here for f plus g, I'm going to take f of x plus g of x. I'm going to take the entire functions and combine them. I'm going to combine like terms. And put it in standard form. And that's what I get for f plus g. Again, we can write it like that if we want to. As far as my domains go, there's nothing I can't plug into f of x. I can plug in positive, negative, zeros, fractions, rational, irrational, any real number. Same thing here in g of x. We can plug in any real number. So my domain here, all real numbers. I have nothing I can't plug in. There's no square roots, no division by variables, no absolute values, no reason I can't just plug in any of our values. Okay, here for the subtraction, I take 2x squared plus 8 minus g of x, x minus 3. And again, if you always want to plug these in parentheses, you sure can, because we have to remember to distribute this subtraction. It's like we're multiplying by a negative 1. So I'm going to have 2x squared plus 8 minus x plus 3. Most people remember to change this sign, but forget about this one here. Don't let that be you. Now, we can combine our like terms, just like we did with the addition. 2x squared minus x plus 11. And again, all real numbers here. In example 2, we're multiplying and dividing functions. So here are my f of x and my g of x again. We want f times g and f divided by g. So f of x, x squared minus 9, times g of x, x plus 3. Here I have a binomial times a binomial, so I'm going to FOIL. Firsts, outsides, insides, and lasts. Then just combine my like terms, or write it in standard form if we have nothing to combine. And this is f times g. My domain, here there's nothing I can't plug in, and there's nothing I can't plug in. Again, there's no square roots, there's no division by 0, no absolute values to worry about, so all real numbers. Here for f divided by g, I'm going to take f of x divide by g of x. And I know I scooted the page up so we couldn't see those, but they are there. We always want to simplify if we can. So we can factor our numerator. It's a difference of squares, x minus 3, x plus 3. Or we want to multiply to 9, subtract to 0 x's over x plus 3. Now, when all we're doing is multiplying, we can cancel out factors. X plus 3 divided by x plus 3 is just 1. And that works when we're multiplying because it's like we divided it out, and division gets rid of multiplication. It doesn't work the same if we're adding or subtracting, so keep that in mind. And here we get x minus 3. As far as our domain goes here, guys, it's the same domain we had for multiplication, except there's going to be a value or values that it can't equal. G of x here, and it's from our very original problem, our very original g of x, cannot be 0. So x plus 3 cannot be 0. We can't have division by 0. So we subtract 3. And x cannot be negative 3, which means our domain is all real numbers not equal to negative 3. Feel free to pause here and give these a try if you'd like. Same idea. I'm going to take f times g, so my entire f function times my entire g function. Here I have a trinomial times a binomial, so we need to multiply these, and it's not just FOILing, because I need 6 terms before I combine them. We can set this up as a table if we want to, or we can just distribute as long as we make sure we get every product. Here I get 9x cubed minus 33x squared minus 12x plus 3x squared minus 11x minus 4. Now I'm going to combine my like terms here. 9x cubed minus 30x squared minus 23x minus 4. As far as my domain goes, there's nothing I can't plug in here, and there's nothing I can't plug in here. Again, no square roots, no division by 0, no absolute value, no reason that we can't plug in any number we want to. So my domain, all real numbers. F divided by g means I'm going to take f divided by g. And remember, we want to try and reduce here wherever possible. So I'm going to factor my numerator using the swing method. Swing the 3 to the back. Multiply to 12. Subtract to 11. 12 and 1. Don't forget that we have to undo that swing. So since I multiplied by 3, I'm going to divide by 3. I get x minus 4, 3x plus 1. And that's still divided by 3x plus 1. Again, all I did was factor my numerator and bring down my denominator. We can cancel things as long as they're the exact same thing. Anything divided by itself is 1. So f divided by g here is going to be just x minus 4. As far as my domain goes, I'm going to have the same domain as I did for my multiplication, except my denominator, or g of x, cannot equal 0. So here, and I know that we canceled it out along the way, but that doesn't matter. It's still a problem if at any point we have that division. So g of x here, 3x minus 1, cannot be negative 1/3 when I solve for x there. So our domain is going to be all real numbers not equal to negative 1/3. We also could have used long division here. So instead of factoring, if you're like, yeah, I don't really want to factor that, or you struggle with factoring, we could have used long division. And as long as our remainder is 0, we know that 3x plus 1 was a factor, and it would have canceled itself out by division. And whatever we had left would have been our simplified version of that fraction. And we'll continue in the next video.